Algebra 2, Common Core, the discriminant. So the discriminant is part of our quadratic formula. Let me just read a couple of these sentences. But first, you should know your quadratic formula. You don't have to memorize it. It's given to you on a reference sheet, but you should still be very familiar with it. And the quadratic formula, there's a lot of different ways it could give us answers, and a lot of that depends on what's in here. And that's what's called the discriminant, the part that's in there, because based on that, this could go a lot of different ways. If it's negative, then we're going to have imaginary roots. If it's 0, then something happens. If it's a square like 16, then we have rational. And so, there's different, based on the result of b squared minus 4ac, there's a lot of different things we can get from our quadratic's roots without even finding the actual roots, just finding information about them. So quadratic equations can have real or complex solutions. And that results in this number being positive or negative, because we know the square root of a positive number is real. Right? Square root of any positive number is real. It may be rational or irrational, but it's definitely real. But if this comes out to be negative, well, the square root of a negative, as we learned, is, imaginary. So that's there. The quadratic formula gives us these solutions. The b squared minus 4ac part of the equation is called the discriminant. And it's useful in determining the nature of the roots without finding out the actual roots. So we basically just get hints about the roots. We find out if they're real or imaginary. And basically, if the discriminant part is positive, then they're real. If it's negative, our roots are imaginary. Now, if it is real, the question becomes rational versus irrational. And that has to do with whether or not it's a square number or not. If it's square, like 4, 9, 16, 25, well, we know the square root of squares are rational. But if it's not, like if we get 17 in here, the square root of 17 is irrational. And we also find out root multiplicity. Quadratic, a parabola, let's say now I have an axis here. There's a couple things that could happen. It could be hitting in two different spots. And these spots could be rational or irrational. But they're two different roots. Each with a multiplicity of 1, because quadratics are degree 2, and I see 2 roots here. And that's going to come up when there's a positive number in here, whether it's square or not. Like I said, these could be rational or irrational. And then it's also possible for us to have just one root of multiplicity 2, and we see it kind of bounces when it's in even multiplicity. And what's going to happen as a result in here is when this number is 0, if the discriminant is 0, we get only one root. Because remember, there's a plus or minus in front of it, and that's what ultimately gets you two different roots. Like if this came out to be 5, we'd have plus rad 5 and minus rad 5. Those are two different things. So that'll give you two different roots, one with the plus, one with the minus. But if the discriminant is 0, if we end up with a 0 in here, well, plus 0 and minus 0, those are not two different things. You don't get two different answers. So you just get one answer. And if you only have one root and you're a degree 2 equation, it has to be multiplicity 2. Because you can't have one real and one imaginary. Imaginaries always come in pairs. They come in conjugate pairs. And so that would be if our parabola wasn't hitting the x-axis at all. And so that would result, if we had a negative in here, this is what we'll see. So all of the different types of roots we could have 2 roots, we could have 1 root, we could have 0 roots. We could have 2 rational roots, 2 irrational roots, 2 imaginary roots. And all of that is depending on what happens with this square root as part of your quadratic formula. Over here, these are just examples of if our discriminant is positive. Remember, this is greater than 0, so positive. Then what we see is we get 2 roots. So when this happens, we get 2 real roots. The question is, are they rational or are they irrational? And so that depends if this is a square or not. But we definitely get 2 real roots. 2 real rational roots, 2 real irrational roots. But 2 real roots, each with multiplicity 1. Now, if our discriminant is 0, again, because there's a plus or minus in front of it, that whatever this number is, positive plus it, minus it, that's 2 different things. result in two answers. But when it's 0, plus or minus rad 0, plus or minus 0, there's not going to get two different things. And so we end up with one real rational root with multiplicity 2. So if the discriminant, if the b squared minus 4ac, the part that's under the square root, if that comes out to be 0, we will end up with one real rational root with multiplicity 2. And sometimes what we say here in these two cases is we say that the roots are unequal. Unequal, basically meaning that they're two different things. And sometimes we call this equal roots. Like there are two roots, but they're really the same root twice. That's why we call it multiplicity 2. But if you ever hear a problem or see a problem referring to the roots being equal, what they really mean is a single root with multiplicity 2. And that only happens when the discriminant is 0. See, this could happen with a positive number. Our discriminant could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, so on, so on. So whatever your positive number is, you're going to get two roots like this. But if it's 0, you're going to get one root multiplicity 2. There's only one discriminant value that gives us this case, and that is 0. If we have a negative discriminant, if the b squared minus 4ac comes out to be negative, well, the square root of a negative, regardless of anything else, is imaginary. And we end up with imaginary. Ooh, that's sloppy. Let me rewrite that a little bit. Imaginary roots. And we actually said that there's two of them. It might be like 2 plus 5i and 2 minus 5i. They're what we call conjugates. So we do get values for them, but they're imaginary because it's not hitting the x-axis at any spot. It's hitting an imaginary axis. So it's not really a real solution. So what you usually see for these questions is sometimes asking about discriminant values. But what I want to do here is just determine the nature of the roots. So we're going to do the discriminant for these. Not the entire quadratic formula, just the b squared minus 4ac part. And based off of that, let's determine what the roots are going to be like. So for this one, b squared minus 4ac. B, remember this is a, b, and c. And so b squared, that would be 3 squared minus 4 times 9 times negative 4. And you can type that exactly into your calculator as you see it. You could use your parentheses and do 3 parentheses squared minus 4 parentheses 9 parentheses negative 4 parentheses, and just hit enter. You don't have to use your calculator, of course. You can do it any way you would like. But this comes out to be rad 153, or 153, right? Yeah. And the reason why I say rad is because we know that if we were to do the whole formula, there'd be some negative 3 plus or minus the square root of this over 2 times 9, 18. But really, it's just this number right here. Because it's positive, tells me that it's real. This is not square. Positive tells me real. Not square tells me that it's irrational. And the fact that it's not 0 tells me my roots are unequal. And this basically means I'm going to have two different roots, each with multiplicity 1. Let's try another one here. So b squared minus 4ac. This would be negative 10 squared minus 4 times 1 times 25. This ends up being 100 minus 100, 0. Now, 0, the square root of 0 is real, so we can say it's positive. 0, positive, or negative is kind of in between. We'll say it's positive, so it is real, and it is rational. Now, it's kind of a square, right? 0 squared is 0. We don't really think of it as that. 0 is kind of a unique number with a lot of its properties, but it is rational because the square root of 0 is 0. The key here is that the roots are equal. And what that really means is because, again, if I have my 10 plus or minus rad this over 2, this plus or minus rad 0 is not going to do anything. So when our discriminant is 0, we get one root with multiplicity 2. One single root with multiplicity 2, and that's going to be when it bounces on the x-axis. All right, my last example over here, b squared minus 4ac is negative 4 squared 16 minus 4 times 1 times 13. I end up with 16 minus, I don't know, what is that, 20, 40, 50 something. Let me just do that real quick. Parentheses, I don't want to do the mental math wrong in the video. So negative 4 squared minus 4 parentheses 1, which we don't really need, times 13 is negative 36. And so the fact that this is negative means that our roots are imaginary. The negative gives us imaginary roots. And then there's nothing else that matters. There's no rational or equal or multiplicity. It's imaginary. That's all you need to know. And a good way to check these is to type them into your calculator, and you can see here that my blue one here has 2 unequal roots. Now my calculator is not showing me that they're irrational, but I do see that there's 2 of them. And so they're unequal, they are real. The one I did here in red, I see because it has a discriminant of 0 that there's only 1 root and it's bouncing. It has a multiplicity of 2, but it is real. And then the one I did in black works out that because it's negative, that means imaginary, and you see in my black parabola here isn't even touching the x-axis. So you can get a lot of this information also by taking a look at it on the graph. All right, that's your discriminant. See you.